Welcome to Golden Software's video training for Surfer 13. Surfer is a versatile gridding, contouring, and surface mapping software package. In this demonstration, I'll be explaining the different map types available in Surfer. There are 13 map types in Surfer. What type of map you create depends on the type of data you have. Base maps are created from imported base map files such as DXF, shape, or an image file like a JPEG or TIFF. Base maps from servers are downloaded from online servers and imported directly into Surfer. Post and classed post maps are based on data files, such as text files, CSV files, or Excel spreadsheets. They post points at certain XY locations given in the data file. The other 9 map types are based on grid files. Grid files can be created directly in Surfer from XYZ data files by clicking the Grid Data menu command. Or you can obtain grid files from other sources such as downloading them from the internet, such as USGS DEM files, or creating them in other software packages, such as Esri products. I will create an example of each map type. To create a new base map, click Map, New, Base Map. In this case, I'll select a vector file containing polygons. Select the ca2010.gsb file and click Open. Base maps display boundaries on a map, such as areas, curves, points, and text, to show features such as roads, buildings, streams, city locations, and so on. This particular base map shows the county outlines in the state of California. I can also import geo-referenced imagery, such as an aerial photo, as a base map. I will right-click over the map in the Object Manager and click Delete. To create a new base map from a server, click Map, New, Base Map from Server. Select the category of file you want, and then select the server and layout you want. I'll expand the Imagery category, expand the NAIP color imagery for US server, and select the USGS EROS Ortho NAIP layer. You can select the area to download and the resolution. Click OK and the data is automatically downloaded and imported into Surfer properly referenced. I will right-click over the map in the Object Manager and click Delete. Post maps show data locations on a map. To create a post map, click Map, New, Post Map. Select the demogrid.dat file and click Open. A point will be posted at each XY location in the data file. You have complete control over the layer properties by selecting the Post layer in the Object Manager and editing the properties in the Property Manager. You can set which columns to use as the X and Y data columns, or change the symbol size, color, shape, and you can choose to label the points with data from the data file. I will move the map to the left so we can compare a regular post map with a classed post map. Classed post maps are very similar to post maps. They also show data locations on a map, but also allow you to specify classes based on a third variable and change symbol properties for each class. Classes can be saved and loaded for future maps. To create a classed post map, click Map, New, Classed Post Map. Select demogrid.dat and click Open. You can see that the classed post map puts a symbol at the same location as the regular post map, but the symbol properties are dependent upon a third variable, called the z-coordinate. Classed post maps divide the z-coordinates into numeric classes, and each class can have its own symbol properties. You can edit the properties of each class by clicking the Classes tab and clicking the Edit Classes button. The number of classes, numeric range for each class, and the symbol properties can be edited here. I will delete both maps by clicking Edit, Select All, and then clicking Edit, Delete. Now we will discuss the grid-based map types in Surfer. The most commonly used grid-based map in Surfer is a contour map. Contour maps are two-dimensional representations of three-dimensional data. To create a contour map, click Map, New, Contour Map. Select demogrid.grd and click Open. Contours define lines of equal z values across the map extents. The shape of the surface is shown by the contour lines. Select the Contours layer, and in the Property Manager, click the Levels tab. You will have full control over the contour interval, fill colors, line, and label properties. I will move the contour map to the left of the screen so that we can view it alongside some other map types. Image maps are raster images based on grid files. Click Map, New, Image Map. Select demogrid.grd and click Open. Image maps assign colors to grid cells based on the Z values in the grid file. By default, Surfer will interpolate the pixels on the image map to create a smooth gradation of colors and include hill shading. You can turn both of these options off. Select the image layer in the Object Manager, and in the Property Manager on the General page, uncheck Interpolate Pixels. If you have a relatively low-resolution grid file, this can make the map look blocky or pixelated, as you can see here. You can also uncheck Enable Hill Shading to turn off the hill shading to see the flat map of colors. Click on the map to select it, and press the Delete key on the keyboard to delete it. The next map we'll make is a shaded relief map. Click Map, New, Shaded Relief Map. Select demogrid.grd and click Open. Shaded relief maps are also raster images. Select the Shaded Relief layer to see the properties in the Property Manager. Shaded relief maps assign colors to grid cells based on Z values, but the colors are based on the slope orientation relative to a light source. The light source can be thought of as the sun shining on a topographic surface. Click on the map to select it and press the Delete key on the keyboard. Vector maps display direction and magnitude data using individually oriented arrows. Vector maps can be created using the information in one grid file or two grid files. To create a one-grid vector map, click Map, New, One Grid Vector Map. Select demogrid.grd and click Open. At any grid node on the map, the arrow points in the direction of the steepest descent, and the arrow length is proportional to the slope magnitude. You have full control over the properties of the map in the Property Manager. You can set the scaling of the vectors, the frequency of the vectors, and you can choose various colors and styles for the symbols. Two-grid vector maps contain Cartesian or polar data. With Cartesian data, one grid consists of X component data and the other grid consists of Y component data. With polar data, one grid consists of angle information and the other grid contains length information. Click on the vector map to select it and press the Delete key on the keyboard. Watershed maps display regions draining into a stream, stream system, or body of water. Click Map, New, Watershed Map. Select demogrid.grd and click Open. A watershed map reads the data from a grid file and splits the grid up into basin or catchment areas. Stream paths are calculated based on the amount of flow into the grid node from all surrounding grid nodes. Each catchment area has a stream where water will collect from any point within the catchment area. You can edit the stream and basin options by clicking the Watershed layer and editing the properties in the Property Manager. Click on the watershed map to select it and press the Delete key on the keyboard. 3D wireframes use lines to represent the 3D shape of a grid file. Click Map, New, 3D wireframe. Select demogrid.grd and click Open. Wireframes are created by connecting Z values along lines of constant X and Y. The more grid lines the grid file has, the more wire lines will be shown on the map. Blanked areas will be drawn at the base of the map. You can overlay contours, post, and vector base maps on top of the wireframe, but it is not possible to overlay images on wireframes or to overlay multiple wireframes together. I'll move this map up a little so we can compare it to a 3D surface map. 3D surface maps are fully rendered, colorful 3D representations of a grid file. Click Map, New, 3D Surface. Select demogrid.grd and click Open. The colors, lighting angles, and optional mesh lines can all be customized on a surface map. Any other map type can be overlaid with a 3D surface map. Multiple 3D surfaces can be layered to create a block diagram, and images can be draped on the 3D surface. I'll go ahead and select both the wireframe and surface maps and press the Delete key on the keyboard to delete them. The last map type is called a viewshed. Viewsheds show areas that are visible or invisible from a stationary transmitter location. Viewsheds can only be added to an existing 2D grid-based map and cannot be created by themselves. I'll go ahead and add a viewshed to the remaining map. I'll select the contour layer and click Map, Add, Viewshed. At this point, the cursor turns into a cross shape. Click on the map where you want the transmitter location to be. The viewshed is created. A symbol is added to the transmitter location, and the viewable area from that point is indicated by a shaded green polygon. You can select the viewshed layer and adjust any properties in the Property Manager, such as the transmitter location, fill properties, showing the invisible areas instead of the visible ones, or the view properties. This concludes the video training for the available map types in Surfer 13. If you have any additional questions, please contact Golden Software.